Alright, had a request for this one in Finite math class. This is manipulating formulas. The formula we're going to manipulate today is called the Pythagorean theorem. A squared plus b squared equals c squared. It's one of the easiest formulas in mathematics to memorize. It kind of just flows nicely. It has to do with right triangles. Where the two legs are A and B, and this hypotenuse is C. It basically says that if you know two sides, you can always find the length of the third side. As long as you know any two of these three sides, you can always find the length of the third by using this formula. But none of that's really important for what we need to do. We just need to manipulate this formula. When you're asked to manipulate a formula, you're going to take one that's pretty standard and pretty well known, but you're going to be asked to solve for some part of it, like this. Suppose it says solve for b. To solve for a variable, you have to have it by itself on one side of the equal sign. B is located up here to the left of the equal sign, and he's definitely not by himself. A squared is over there with him, and he also has a square that we need to get rid of. So if I rewrite the formula here, I start to get to work on getting b by itself. The first thing I focus on is a squared. I'd really like to make that go away. In equations, you can make things go away by introducing them to their opposites. This is a positive a squared. So if I introduce them to negative a squared, together they become 0. In our case, they'll vanish. But there's a rule for equations. Anything you do to one side, you must do to the other. So if you subtract a squared from the left-hand side of the equal sign, you may have seen teachers do this in the past, you must also do it on the right-hand side, over here where the c squared is. That would make b squared come down alone, because the a squared's canceled, equal to c squared minus a squared. We actually can't perform that operation. We cannot subtract these two, because they are not like terms. One's a c, one's an a. So if we can't combine them into one term, keep them as two separate terms, and you just write it as c squared minus a squared. Just the way it's read up and down, just put it side to side. Last thing for the b, you need to get rid of the square. The opposite of the square is the square root. Anything you do to one side, you must do to the other. So if you're manipulating this formula and you're solving it for b, b is going to be equal to the square root of c squared minus a squared. Catch you next time, Bears.